Hi, so today we're going to be covering section 6.3, days 1 and 2 for square root functions. Alright, I just got done doing 4 problems and realized I didn't hit record, but instead I took a picture, so here we go. I'm about to explain what I just did on the last 4 problems. Super easy. Here we go. So when I have a graph that looks like this with that curve, it is called a square root function. So this is a curve. It's represented by this equation. When you see this equation or a graph that looks like this, that starts at 0, 0, that's typically going to be our parent function. It's a starting point. It starts at 0. All right, so if we look at this first example here, my parent function starts at 0, 0, and curves, just like this parent function. All right, but in my equation here, for this first example, it says x plus 2. The opposite of a positive 2 is a negative 2. And if I start at 0, a negative 2 goes left on my graph. Negative 1, negative 2. So I drew a point, and I made my new graph. Okay? So the key thing to remember is when it's a number under the square root, you're moving either left or right depending on what that number is. If I look at my second example here, I have x minus 2. The opposite of a negative 2 is a positive 2. So from 0, that's my parent function. From 2, the opposite of a negative 2 is a positive 2. So I'm going to go positive 2. Plus 1 plus 2. So I moved right. So for this one, I can circle right, and this one I'll circle left, because from 0, I moved left, and this one I moved right. All right? So just remember, when you're moving left or right, it's only when you have a number under the square root. Down here, we have the square root of x, and we have numbers off to the side. When you have a number off to the side, your graph is going to move up or down, but this number is going to stay the same. Here, for these ones, because they were under the square root, they moved left or right, and we did the opposite. When they go left or right, you do the opposite. When it's a number off to the side, that number stays the same, but it goes up or down. Since this is a positive 4, from 0, 0, my graph is going to go up 4. So I'm going to go up 4. This one over here is going to go down 4. So I've got up 1, 2, 3, 4. Draw my dot. There's my new curve. Maybe I'll do it as a dotted line so you remember which one is the new one. All right. And over here, I have a negative 4. So I'm going to go down 4. Down 1, 2, 3, 4. Draw my dot. And here's my new curve. So again, numbers under the square root move left or right, and you do the opposite of whatever number is under that square root. Down here, when you have a number off to the side, it's going to either go up or down, but that number stays the same. All right? As I move down to these 2 problems here, now you'll notice you have a number under the square root and off to the side. So let's look at number 5 first. Since I have a positive 2 here, the opposite is a negative 2, and negative 2 travels left. So here's my graph, here's my parent function, and from here I'm going to go negative 2, negative 1, negative 2, but I'm going to stop there for 1 second, kind of like a bus stop. You travel this way, but you're not at your final destination yet, because this says plus 4. So now I need to go up 4. So I'm going to go up 1, 2, 3, 4. So here, the opposite was a negative 2. So I went negative 1, negative 2. There's my bus stop. And now I need to go up 4. Up 1, 2, 3, 4. Draw my dot. Draw my new graph. It's that little curve. And that looks like super confusing because I've got this here. So here was my dot, and there's my new graph. All right. Over here, if you notice, these numbers are the same as what I have here and here. So down here, the only difference is instead of doing one thing, either going up or down or left or right, I do both. I have to move one way or another, and then I either go up or down. But here, I moved left, and then I went up. So over here, I've got a -2. The opposite of a -2 is a +2. +2 travels right. Here's my graph, and here's my parent function. And if I travel +2 from here, I'm going to do a bus stop. 1, 2. So I moved right, and now I have to find -4. So I'm going to go down 1, 2, 3, 4. Draw my dot, and draw my new curve. Voila. So I did two things here. I did the opposite of what I saw here, +2. So I moved +2, and then I moved down 4. Boop. So sometimes you can do one thing like we did here, two things like what we did down here. Here we moved left and then up. Here we moved right and then down. So these ones, you do one thing. Down here, we did two things. Now I'm going to show you something where we can do 3. The most we could ever do is 4. So that means we're halfway there. Okay. So let's see here. Let's use the same numbers. Let's do y equals the square root of x plus 2. Let's see, plus 4. But the one thing that we need to watch for is sometimes you're going to have a positive number out front, and then sometimes you're going to have a negative number. Plus 4. All right, so when we have a positive number out front, our graph is going to open up, kind of like with our parabolas. Remember when we had a positive number, our parabolas opened up like that? Same thing here. We have a positive number, so our graph, kind of like if we had our parent function, it's going to curve up. Here, since it's negative, it's going to reflect and curve down because that is negative. All right, so hopefully you can start to identify that when we have a positive number, it goes up, a negative number, it goes down. All right, so we're going to start off, like I said, with those two types of problems. The only thing now is I'm going to add a positive number in front or a negative number in front. So let's see, we did 6 on the front, here's 7. So let's say I have y equals a positive 2 square root x plus 2 plus 4 off to the side. And let's say over here I've got, that's number 8, we've got y equals -2 square root x plus 2 plus 4 off to the side. All right, perfect. So here's the tricky thing. When I have a positive, it opens up. When I have a negative, it goes down. There's also something that happens if I have numbers bigger than 1 or numbers between 0 and 1. All right, so you know what? For the sake of this problem, I'm going to change this just to a 1. Okay, so for this, here's our parent function. It starts at 0. Positive 2. The opposite of a positive 2 is a negative 2. That means I'm going to go left, negative 2. Negative 1, negative 2. Here's my bus stop. And then because this is a positive 4, I'm going to go up 4. Up 1, 2, 3, 4. Here's my dot. But now I have to pay attention to if this is a positive number or a negative number. Since it's a positive number, it's going to curve up. Over here, I have a negative number. So if you notice, the only difference is a positive versus a negative. So let's go ahead and draw our parent function. I have a positive 2, so the opposite is a negative, and it's going to go left because negative numbers go left. There's 2. Here's my bus stop. I'm going to wait here. Now I have a positive 4, so I'm going to go up 4. 1, 2, 3, 4. Draw my dot, but because this is negative, my graph curved down. It no longer curves up, because if it goes up, it's a positive number. If it's a negative number, it curves down. Whew, we're getting to some tricky ones. All right, one more type of problem. All right, so let's draw a fun little line here, because I've been doing that with each different type of problem. So hopefully you guys can see the difference. Let's see. These should be the last two types of the last types of problems, but there's going to be 2 of each. So let's call this 9. Let's call this 10. 11 and 12 will be our final ones. So we're almost there. Hang tight. Oh, man. Doing math on the floor is so much fun. Okay. So remember when I said that these numbers could be different? So like before I had drawn them as a 2, I changed them to a 1 so that way we could start with a more basic problem. So here I'm going to put y equals, now I'm going to change it to a 2. I wanted to show you positive and negative before I changed the type of number. So now I have x plus 2 plus 4 off to the side. I'm just going to do this before I start writing this one over here. So again, if I'm looking at a graph, I've got my positive 2, and the opposite is a negative. Remember, that's what's under the square root. So it's going to go left. So we start at 0 where the parent function is, and we're going to go left 2. 1, 2. Here's my bus stop. And now I'm going to do the number off to the side, which is a 4. So I'm going to go up 4. 1, 2, 3, 4. So I'm going to draw my dot here. So I went over 2, up 4. Now, remember, this is a positive, just like that one was. So my curve would normally go like this. But because I have a number that's bigger than 1, when you have a number that's bigger than 1, your graph is going to get, let's see, it's going to get narrow. So instead of it doing that normal curve, it's going to do this. So I know it's hard to tell a difference between just a regular curve, but you see how it was like the same type of curve as this? If I had a number 2 here, my graph would do this. It would get narrow. It would go from like normal size to just a teeny tiny bit smaller. All right. I'm going to show you an example over here if it is, if it's a negative. So let's say I have y equals -2 square root x plus 2 plus 4 off to the side. Here's my regular graph, 0, and my parent function. The opposite of a +2 is a -2, so I'm going to go left, 1, 2, there's my bus stop, up 4, 1, 2, 3, 4, draw my dot, but because this is negative, my curve is going to go like this, but now it's not just a 1. When you have a number that's bigger than 1, negative tells me that the graph reflects and it goes down, but I'm just looking at my number. Since I have a number that's bigger than 1, here, positive or negative just tells me if it's going to go up or if it's going to go down. This one was positive, so it went up. Then you look at your number. Because it's a number bigger than 1, it gets narrow. So here, negative told me that it went down, and now because it's a number bigger than 1, I have a 2, so a 2 is bigger than 1. It's going to get narrow. So what I'm going to actually do here is I'm going to take a color. Here, this is what my regular curve looks like. And when it gets narrow, it gets, like, instead of it being a normal size, it gets smaller. It kind of like with our parabolas, when they got narrow, it got thinner. So down here, instead of it being our normal curve, it's gonna do this. Okay? I know, again, kind of confusing. Don't worry about it too much. If you have questions, just ask. Okay? Last two types of problems. Let me draw them and get them set up really quick. Okay. All right. 9, 10. This one's 11. And then I promise I'll be done with this. All right. So I have y equals, I'm going to do a positive 1/2. Square root x plus 2 plus 4 off to the side. Over here, I'm going to, so here it was a positive 1/2. Over here, I'm going to do a negative 1/2. So this one is number 12. There's 11. So I've got y equals negative 1/2 square root of x plus 2 plus 4 off to the side. All right. So here, I've got, let me draw my graph. Perfect. And there's my parent function. All right. Always start under the square root. The opposite of a positive 2 is -2. -2 goes left. Left 1, 2. There's my bus stop, my stopping point. That's a positive 4, so I'm going to go up 4. 1, 2, 3, 4. Draw my dot. It's a positive number, so I know it's going to open up. But now I have a number that is between 0 and 1. A number between 0 and 1. I know that 1/2 comes between 0 and 1, so I know that it's a number between 0 and 1, because half is the halfway point between 0 and 1. Hopefully we already know that. Hopefully that's just a review. But when you have a number between 0 and 1, your graph is going to get wider. So up here, you see how it got smaller, or well, narrow. It got narrower. But here, when it's that number out in front is between 0 and 1, it's going to get wider. Sometimes narrow can be interchangeable with the word compress. Wider is often interchangeable with stretch. So we're going to say it's going to stretch. All right, I'm going to highlight that. And we're on our last example. I'm so sorry, guys. I know this is a lot of information, but again, it should just be review. I'm posting these for anybody who is super confused, maybe lost, or maybe was absent. All right. So here we've got our number under the square root. Let me draw my little graph here. Here's my parent function. All right, positive 2. The opposite of a positive 2 is a negative 2, and negatives go left. 1, 2. If you notice I'm using the same numbers, the reason for that is because I want you to see the difference between each of the different types of problems. Okay, so I had positive 2, the opposite is a negative 2, and negatives go left. So I go left 1, 2, there's my bus stop, and then number off to the side is positive 4. Up 1, 2, 3, 4. You know what I should draw? I should draw arrows. I just drew those. Sorry. It's hard to watch my paper and my phone at the same time. Positive 4, so we went up. So negative 2, 1, 2, bus stop. And we have to do up 4, up 1, 2, 3, 4, draw my dot. Because this is a negative, I know that it's going to curve down. But because I have a number between 0 and 1, I'm going to get wider, stretch. It's going to get a little bit chubbier. Whereas these ones up here got stretched smaller. These ones compress wider. Again, hopefully we're able to see the difference between each of these. Please email us or ask us questions if you have any.